The side length of the triangle, in step 0, is 1 unit. Find the total perimeter of all the blue triangles in each of the steps shown. The perimeter is the total length of the outline of a shape. Let's focus on the first 2 steps. In step 0, there is one blue triangle, and the sum of all the side lengths is 3. So, the perimeter is 3. In step 1, there are 3 blue triangles, with side lengths equal to 1/2. Focusing on one blue triangle, the perimeter is 3 times 1 by 2. Multiply this by 3, to obtain the perimeter of all 3 triangles. Now to find the common ratio, divide this by the term obtained in previous step. This gives 3 by 2. Now, multiplying each step by this 3 by 2, we can obtain answers to the next step. So we can write these terms as multiples of 3 by 2, as shown. Finally, for the step n, here is the perimeter of all the blue triangles. Find total perimeter of blue triangles in step 35. For this, use the formula for the nth step, as shown, and set n equals 35. And here is the answer. Let's look at the total area of the blue triangles at each step of the Sierpinski triangle. For an equilateral triangle, the area is given by this equation. Here, L is the side length. Let's focus on the first 2 steps. For step 0, considering the side length of 1 unit, the area becomes. In step 1, there are 3 blue triangles, and the side length of each is 1/2. Let's find the area of one such triangle as shown. Then multiply by 3, in order to obtain the total area of all 3 triangles. Now, to find the common ratio, divide this by the term obtained in the previous step. This gives 3 by 4. So our common ratio, or the multiplication factor, is 3 by 4. Now multiplying by this 3 by 4, consecutively, we can obtain the total area of all the blue triangles in step 2, step 3, and so on, as shown. So, we can write each term as a multiple of 3/4 in this form. Finally, for nth step, the total area is given by this term. Let's look at the total area and the total perimeter of all the blue triangles as n tends to infinity. For the area, write the formula for the nth step, and find the limit as n approaches infinity. This can be written this way. Note, 3 by 4 is less than 1. As n increases, the limit of this function approaches 0. A graph of this function is shown. It can be seen, as n gets large, the function approaches 0. Now for the perimeter. Write the formula for the nth step, and find the limit as n tends to infinity. This can be written in these 2 forms. Let's consider this first one. Since 3 by 2 is greater than 1, as n gets large, the value of this function increases, so the limit, in this case, is infinity. This can be seen from the graph of this function, as shown.